Okay, so let me. Now I'm showing you back the screen again. So can you? I hope you can see the screen. Okay, the screen again, which is the members with incline, a frame with inclined members. So. Okay. So now the first thing that I would like you to recall again is how to handle distributed load. Distributed load must, first thing you must know, get the equivalent load, get the load which is equivalent to that distributed load by multiplying the intensity, which is 10 kilonewton per meter, and multiply with the length where this load is distributed. So in this case, for this incline member, the load is distributed along the incline member. You need to find this length here. You need to find this length. So how to find this length here is given to you. If this is 4, this is 3. So here is exactly 4. So we know that this height is 3. Or if the angle here is given, then you can, if this is 4 meter is given, then you can find what is the height here, and you can find what is the length here by using the relationship of this length and this length. So here, the total length here, the total length of CB, the total length of CB here is, you can find that easily, is 5 meter. So the total load here, the red arrow that I show here, so is equal to, so the load here, F, if I put the symbol F here, that would be equal to 10 multiplied with 5, which gives you 50. And don't forget, it is kilonewton now, because it's 10 kilonewton per meter multiplied with 5 meters, so you get 50 kilonewton. So that is the first thing. And when we put equilibrium of forces, then we need this. When we consider equilibrium of forces, so we need to use this force. Consider this force going downwards. Next, when we need to consider this force in equilibrium, a moment equilibrium equation, you need to know where this is acting. Where this is acting. For this uniformly distributed load, this F 50 kilonewton acts in the middle of this length. In the middle of this length, at this point here. And because it is acting in vertical directions, so you need to know, for example, if you want to take moment at, take moment at D, so the perpendicular distance will be this horizontal distance. So if take moment at D caused by this distributed load acting on inclined member, it will be 50 multiplied with this length here. And what is this length here? This length is 2 meter plus this length. What is this length here? This length is also 2 meter, because this is acting right at the middle of this inclined member length, because it is UDL right in the middle. So right in the middle, if this is 4 meter, so this one becomes 2 meter. So the moment caused by F will be 50 multiplied with 2 plus 2, which is 4 meter at point D in counterclockwise directions. So that is the important point to take note. It is similar to this part of the loading as well. This part of the loading now is its incline. So the length that you need to consider is multiplied with this length to get the total load equivalent to this UDL. And take note the direction of actions. the direction of actions, it is acting vertically. So the perpendicular distance to point D will be this horizontal distance. So that is the important point to take note of dealing with inclined members. Okay, dealing with inclined members. Now, next, I show you the solution process. Then you can, for those of you who have gone through, get the answer, you can compare now. So this next slide, I'm showing you force equivalent to UDL. You need to know, get this force equivalent to, this is UDL. So only this length multiplied with this height here. So this is 10 kilonewton multiplied with 2. This is 10 kilonewton multiplied with 5, the inclined member length. This one is 10 kilonewton multiplied with 2 to get this equivalent load, the dotted arrow here. Then location of actions, if it is UDL, is acting at the middle of this place where it is acting. It is acting at the middle of the line here, where it is acting, and the same thing here. So those are the two important things that you need to take note of. Then, depending on whether you want to use it in moment equilibrium equations or force equilibrium equations, then you need to use the force only or find the moment at the point where you want to take the moment. So this is the solution process, the complete solution process that I have prepared. So now this is a free body diagram, so dx, dy, and by. So this is a simply supported frame with inclined member here. So 1, 2, 3. So all the dimensions are given. This is 4 meter, and this 3 meter is not given, but from the inclination information given to us, 4 to 3. If this is 4, distance is 4 corresponding to vertical distance 3, so this becomes 3. So from this 4, 3, we can find this length 5 meter. This length is 5 meter. So if we want to find the reaction forces, so I can start with summation of moment at D, at point D. If I take summation moment at point D, then I can find By directly. So By multiplied with 6, By multiplied with 6, and it is giving me clockwise moment. This is clockwise moment. Then next, I'm showing you here the values and also this correspond to, this one is correspond coming from where. So minus 10 by 2 is the equivalent force of this AB part, AB, and then the perpendicular distance to point D here will be 2 over 2 because acting at the middle here, plus 6. So 1 plus 6. Next, the same thing for this part of the distributed load, UDL. And this is against 10 multiplied with 2 to get the equivalent load. And then perpendicular distance to D will be just 2 over 2 equal to 1. And this is causing counterclockwise moment. This is also causing counterclockwise moment at D. So it becomes negative, negative. And this is the one that we have to take note of. You get the equivalent load first, which is 10 multiplied with the inclined member length and give you acting in vertical directions, 50. 50, then multiplied with the perpendicular distance. So the perpendicular distance will be 2 plus 2 to point D. So this is the part that we have to take note of when there is inclined member. Then solving this, you get By is equal to 60 kilonewton positive, so indicate direction as going up. So now if you go to the next dx here, so summation of force in x direction equal to 0, so you get dx equal to 0 because there is no load which have component in x directions. This is our x. There is no load component in x direction, so dx is equal to 0. And then finally, to find dy, so summation of forces in Fy, so first equilibrium equation, second equilibrium equation, the third one. So going up take going up as positive, so dy plus dy, then minus, so this one minus the equivalent, yeah, the load equivalent to this UDL, uniformly distributed load. So it is 10, which is the intensity of this distributed load, 10 multiplied with this incline length 5. So 10 multiplied with 5, which is going down, because this is acting downward, so it becomes negative. And the same thing for this part, AB here, 10 multiplied with 2, going down, negative. And the last part, CD here, 10 multiplied with 2, also going down, that's why negative. Then we solve for this, substitute the value of By that already obtained from here. So we get 30 kilonewton for dy. 30 kilonewton for dy here. Okay, so this is how we solve this problem. This part here and this part, they are the same. You have already seen how to consider that. So now only the incline part. The incline part is how, this is how we consider. The basic principle is still the same. How we treat uniformly distributed load. Get an equivalent, get the load equivalent to that UDL and indicate, know where it is X, know where is the point of actions. For UDL, it is acting at the middle of this incline member. At the middle of this incline member. So that is how we solve these problems, which we are having incline members. Okay. Now, let me pause for a while and see. So that is the solution process and things that you need to take note of. So when there's situation of incline member, now you know what are the things that we need to follow, important points that we need to take note of when dealing with load acting on incline members. Okay. So before I proceed to the next one, any questions? Any questions from you?